Containers versus virtual machines. Virtual machines were the dominant deployment technology before containers. Containers introduced a lighter and faster approach to application deployment. Understanding the differences helps explain Docker's popularity. In this lesson, we compare containers and virtual machines in detail. Why we need isolation. Applications often require different software versions, different libraries, different configurations, independent execution environments. Isolation prevents conflicts between applications. What is a virtual machine? A virtual machine, VM, is a software-based computer. Each VM contains virtual hardware, guest operating system, libraries, application code. VMs run on top of a hypervisor. Virtual machine architecture. Flow. Physical server-hypervisor-guest operating system-libraries and dependencies-application. Each VM includes a complete operating system. What is a hypervisor? A hypervisor is software that creates and manages virtual machines. Responsibilities. Allocate CPU resources. Allocate memory. Manage virtual hardware. Isolate virtual machines. Popular hypervisors include VMware and Hyper-V. Advantages of virtual machines. Strong isolation. Ability to run different operating systems. Mature technology. Suitable for legacy applications. Virtual machines have been widely used for many years. Limitations of virtual machines. Large disk usage. High memory consumption. Slower startup times. Increased infrastructure costs. Each VM requires a complete operating system. What is a container? A container is a lightweight isolated environment. Contains application code, runtime, libraries, dependencies. Containers share the host operating system kernel. Container architecture. Flow. Host operating system Docker engine container application. Containers do not require a separate operating system. How containers work. Containers use operating system features to provide isolation. Benefits. Lightweight. Fast startup. Efficient resource usage. Easier deployment. This makes containers highly portable. Containers versus virtual machines. Virtual machines include guest OS. Larger size. Slower startup. Higher resource usage. Containers share host OS. Smaller size. Faster startup. Lower resource usage. Startup time comparison. Virtual machine. Seconds to minutes. Container. Seconds or less. Containers start significantly faster. Resource consumption comparison. Virtual machines require more RAM. Require more storage. Containers require less RAM. Require less storage. Containers maximize hardware utilization. Deployment speed comparison. Virtual machines. Slower provisioning. Larger images. Containers. Rapid deployment. Lightweight images. This accelerates software delivery. Portability comparison. Containers package. Application. Runtime. Dependencies. Applications can run consistently across environments. Portability is a major Docker advantage. Density comparison. Single server example. Virtual machines. 10 to 20 VMs. Containers. Dozens or hundreds of containers. Containers allow higher workload density. Real-world example. Web application deployment. Using VMs. Full OS for each application. Using containers. Shared host OS. Multiple lightweight containers. Resource savings are substantial. Security considerations. Virtual machines. Stronger isolation through separate OS. Containers. Lightweight isolation. Shared kernel model. Both approaches have valid use cases. When to use virtual machines. Suitable for legacy applications. Different operating systems. Strong isolation requirements. VMs remain important in many environments. When to use containers. Suitable for microservices. DevOps workflows. CI/CD pipelines. Cloud deployments. Modern applications. Containers are ideal for agile development. Can containers and VMs work together? Yes. Common architecture. Flow. Physical server-virtual machine-Docker engine-containers. Many organizations use both technologies. Cloud computing and containers. Cloud providers extensively support containers. Benefits. Scalability. Portability. Automation. Cost efficiency. Containers fit naturally into cloud environments. Impact on DevOps. Container support. Faster releases. Automation. Continuous integration. Continuous deployment. They are a key DevOps technology. Common misconceptions. Misconception. Containers replace virtual machines. Reality. Containers and virtual machines often complement each other. Both technologies have important roles. Benefits of containers. Faster startup. Smaller footprint. Better resource usage. Easier portability. Simplified deployment. Improved scalability. Comparison summary. Virtual machines. Full operating system. Heavier. Strong isolation. Containers. Shared kernel. Lightweight. Fast and portable. Interview question. Question. What is the primary difference between a container and a virtual machine? Answer. A virtual machine includes a complete guest operating system, while a container shares the host operating system kernel and packages only the application and its dependencies. Key takeaways and lesson summary. Virtual machines provide hardware-level virtualization. Containers provide application-level isolation. Containers are lighter and faster than VMs. Containers improve portability and scalability. Both technologies are valuable in modern IT environments. Docker popularized container adoption worldwide.